Hello friends, welcome to channel study guide. So friends, from this video we will start the RRB JE electrical preparation and also the electronics preparation, and for the electronics there will be different videos, okay, and watch them if you want that. Also because for the electrical and electronics are very related, and some of the questions are some of the syllabus are very close one, okay, and I will discuss them later. But before that we should discuss the electrical previous year solved. Now the electrical question, what are the electrical questions in the previous year? Let us discuss here and solve them too. Now the first one is the 26th August 2015 first shift. We will discuss the 26th of August 2015 first shift, and let us see, watch what are the questions on that shift. So in the first there was 15 question. Previously the RRB paper was a different pattern, okay, there's RRB was a different pattern because on that question paper you will have a 15 question from the electrical, 15 question from the mechanical, 15 question from the electronics and computer, and 15 question from the civil engineering too. So that was a different pattern. But this year in the 2019 the RRB has changed the pattern, okay, so we have to solve all the questions from the electrical from all the previous year, okay. So let us first move on to the first question today. What is the first question of the today? An ohm meter. What is a ohm meter? An ohm meter is a meter which measures the ohm, or that is the resistance. So what is the actually that kind of meter? Okay, the type of meter is moving iron. You have a question mark. Moving iron, moving coil, dynamometer, hot wire. And generally the ohm meter uses it needs to find the resistance, and you can use the DC and the moving coil, one of the accurate instruments, okay. So an ohm meter, the answer will be moving coil instrument, okay. An ohm meter is basically a moving coil instrument which measures the resistance, okay. And you have to remember all those questions and answer for your RRB JE examination for measuring a very high resistance, very high insulation resistance. The question may be asked by a very high resistance or a very high insulation resistance. We should use Kelvin double bridge, Wheatstone bridge, a Megger shearing bridge. This Kelvin double bridge is used for the low resistance, Wheatstone bridge for the medium resistance, shearing bridge for the capacitance, and Megger is for the high resistance. Megger is a mega ohm meter, okay. It consists with an ohm meter with a DC generator, okay, hand driven DC generator. So the answer will be option C, Megger. Let us move to the next question too. The electrical power to a Megger is provided by. Electrical power to a Megger is provided by. In generally the Megger, a shaft is attached like this one, and we have to rotate this one, and when we drive, the flux cuts and the voltage EMF generates. So this is a hand driven permanent magnet DC generator, hand driven. Remember it is a hand driven. In modern electronics Megger, okay, that is a 5 Megger, okay, 5.0 kV Megger. 5 Megger, that means there is a 5 voltage of DC generated voltage of 5 kV. So 5 kV Megger, this is a electronics Megger, and we have to need a switch, push the switch, not very hand driven, okay. Okay, so moving to the next question. So try to remember all those questions and answer, because it's a very important for railway RRB JE preparation. And in a Megger, controlling torque is provided by. In generally the instruments have the controlling torque either by the spring or the gravity, and the damping torque is provided by the eddy current. But in the Megger, the controlling torque is provided by the coil, okay. Later we will study what is the Megger and how the Megger works. The operating voltage of a Megger is about operating voltage of a Megger is around 500, 100 volt, 500 volt, 1000 volt, like this one, okay. 200, 5000 volt, like 5000 volt. These are the Megger operating voltage, and the answer will be 100 volt, okay. Which of the following will have the highest no load speed? Okay, we know that speed is proportional to 1 upon flux. In the DC series motor, at a no load condition the flux is very low, so the speed is very much high, and the DC series motor should not be operated at no load. So answer will be option B, given by the RRB railway board. And the DC motor, the iron loss occurs in both field and the armature, but the iron loss occur in the armature are very high. Okay, and we should consider the losses in the armature, and so the armature are laminated. Okay, this is, if this is the armature, these are the laminated to minimize the eddy current losses. Okay, and there is a holes that when the heat is generated too much high, the air holes, so that the air can pass through this one and it can be cooled down easily. So the DC motor, the iron loss occurs mainly in the armature. Okay, and we should consider the main losses in the armature. Let us move to the next question. The number of the poles in a phase induction motor. The question was asked like this one, not a 3-phase or single phase. They haven't told it. Like induction motor 50 Hz running 1500 RPM. We know that N equals to 120 F by P. Now what is the P? P is 120 F by N. So here if I put down the value of 120 and frequency of 50 Hz and speed of 1500 RPM. Okay, so what I get? I get 4. Okay, they have considered no sleep. Okay, without considering any sleep for this particular induction motor, they have given the answer option C. Okay, they have used this answer. Okay, a power plant usually works on power plant is on which cycle? Otto cycle, binary Vapor cycle, Breton cycle, or Rankine cycle? Okay, power plant, modern thermal power plant works on the Rankine cycle. Modern thermal power plant works on the Rankine cycle. Okay, option D, and you should remember this answer. Turbine used for low head is the Kaplan turbine. You know the Kaplan for a low head, Francis for medium head, and Pelton for high head. Okay, so Francis has a long range, so generally Francis turbine are used too much. Okay, and Francis turbine are used widely. If I think about the choice of application, the Francis is wide. Okay, let us move to the next question. Transformer ratings are usually expressed in kVA because the iron losses are depend on the voltage. Okay, iron losses are depend on the voltage, and ampere, and the copper losses depends on the ampere. So iron losses on the voltage, copper losses on the ampere, but the transformer losses are not depend on the the transformer are not designed on the losses due to the load power factor, because when we design the transformer we does not know what is the load power factor. Okay, a step up transformer increases. A step up transformer, what is the equation for the step up transformer? V2 by V1, that is equals to N2 by N1, and that is equals to I1 by I2. So if it is greater than 1 step up, that means V2 is basically V2 is greater than V1. Okay, V2 is basically greater than V1. Write this equation. This equation comes in the questions too much often. So if V2 is greater than V1, what will happen? That means the secondary voltage is greater than the primary voltage. That means it is stepping up the voltage. It never step up the frequency. It doesn't change the frequency. Okay, try to remember these things. It does not change the frequency or the power. Okay, though there is a power loss, but it doesn't change the frequency. Okay, moving to the next question. In an AC circuit, the ratio of kilowatt to kVA. Now, this is the theta, this is the kilowatt, and this is the kVAR, and this is the kVA. Now, what will happen? Theta, what is the cos theta? Cos theta is the base by hypotenuse. As per the trigonometry, the cos theta is the base by hypotenuse, and in electrical we know that the cos theta is the power factor. So we can write cos theta equals to kilowatt by kVA. So kilowatt by kVA, that means the ratio of kilowatt by kVA represent the power factor. Okay. And the next question, what is written here? Okay, let us discuss this problem wider. So what the question has been asked? Because the question has asked, two resistors of 2 ohm and 3 ohm are connected in parallel. So now I connect 2 ohm and 3 ohm, and this combination in turn is connected in series with the 2 ohm resistor. Then I connected a 2 ohm resistor. This is also 2 ohm, this is also 3 ohm, and 6 volt battery. Now let us connect this with the 6 volt battery. The current in the 2 ohm resistor is, so which 2 ohm? I don't know which 2 ohm. So let us find all the current through this 2 ohm resistor. Okay, through the current, first main current, what is the R equivalent? Now 2 parallel 3, okay, 2 parallel 3, that means 2 into 3 by 2 plus 3, that means 6 by 5. I can write here 6 by 5. 6 by 5 means 1.2. Okay, 6 by 5 means 1.2. Now what is the R equivalent? R equivalent will be 2 plus 1.2, 3.2. Now what is the total current of the circuit? V by R equivalent. How much the V? V is 6 volt and R equivalent equals 3.2 volt. Now it will be 1 point, if I divide by the calculator. Okay, in your RRB exam, calculator will be virtual calculator will be provided. V6 divided by 3.2, 1.875. So you can see this option are not given in your, here the option is not given. That means 1.875 is flowing actually through this 2 ohm resistor, but the option is not given, so it will not be the answer. So let us find for this 2 ohm also. Okay, for this 2 ohm the current will be 1.875 multiplied by sorry, what happens? Multiplied by opposite side resistance divided by total resistance 5. So what I can do, I can I have applied the current division rule here. The current division rule tells us that the opposite side resistance by total resistance. Now 1.875 multiplied by 3 divided by 5. So let us use the calculator again. Okay, the answer will be 1.125. So you can see that 1.125 is still not in the option, so I can't choose any one of them for the RRB. Okay, but you can do your method. Okay, you can do in your method, you still find whatever the answer I have got. Okay, you should rely on your theory, not particular answer key from any boards. Okay, the last question of the session is, a resistance of conductor does not depend upon. So what is the formula for resistance? We know that R equals to rho L by A. Now what I can tell here, that resistance is depends upon rho. Rho is the material. Rho is the material. Resistivity of the material, that means the material, and L is the length. L is the length, and resistance also depends on the temperature. Okay, but I should know the area. I should not know the shape of the cross section. The resistance may be triangular, maybe square. Okay, maybe any shape, maybe circular. Okay, I should know the area. I can find the resistance. Okay, so it does not depend on the shape of the cross section. It depends on the area but not on the shape. So answer will be option A. So I hope I have discussed all the 15 questions and all the 15 questions are very clear to you. So I will discuss the 26th of August second shift and also the third shift. And if you haven't still subscribed our channel, subscribe to our channel and press the bell icon, because we will get more and more question and answer for the RRB JE preparation. Don't miss that out. Press the subscribe icon and press the bell icon. Thank you.